It takes longer to build units, but we can confirm that they're done the right way. We looked at the durability of the unit from start to finish. It really starts with the metal cabinet that we provide, which is an acrylic material.
The reason we use that is because of its tensile strength and how long it lasts in a salt fog environment.
An acrylic, it will not rust.
The beauty of the acrylume is when you punch it and the metal rolls into that punch part, the exposed part gets coated, and that coating is the same integrity of the sheet as you get it in its raw form.
We have a stainless steel condenser pan, stainless steel evaporator pan, stainless steel fasteners on the exterior. It's a little bit thicker, tougher material than the acrylume, so we use stainless steel on all of our components that may hold water for a long period of time.
Coated coil stands up against salt fog. It expands the life of the air conditioner. You can put it into the most extreme environments and it's going to meet that 7-year life expectancy.
This is a Modine Luvada E-coat. It's a dipped E-coat. The cover is powder coated aluminum.
5052, which is a marine grade aluminum.
Standard product is rated NEMA 4. NEMA 4X is available as well.
All of our units are a closed loop system. We don't allow any ingress or any air from the outside to enter the cabinet that we're cooling.
So from the exterior use, they're extremely durable. They've gone through extensive testing at UL and have been certified and listed by UL for that NEMA 4 rating.
Our units are built and designed around GR47 and to meet or exceed NEMA 4.
We use fans from Rosenberg, a German engineered company. Fans have a high IP rating as far as the motor protection, as far as like dust, water.
We use a rotary compressor on a lot of our designs because the rotary compressor versus a reset lasts a little bit longer and doesn't draw as much power. Every TXV that we use is Danfoss, and the reason being because of the durability. With telecommunications, they really need to be a 24/7 unit. They're approved for use on AT&T cabinets throughout the United States. You know, you're always monitoring that temperature. There's no downtime. That unit needs to be able to handle those harsh temperatures and that wide range of temperatures. To us, the refrigeration system is the biggest key to our units. Really test, retest on the line that our refrigeration system is sealed, has the right charge in it, and it's durable, reliable, ready to go, and it'll run for years and years. We have travelers that travel with our unit from the very moment they're created. As it goes down the line, we have multiple people look at that unit to sign off. So like say you were doing station 1 and I'm doing station 2, you're actually going to check my work and then you're going to sign off on it. All the way through the line. So it has all the data from every single one of our tests, wiring, who wired up the unit, who did basically each station, and when it gets to the end, we actually have a quality supervisor that will review all that, compare it to averages and data that we already have in our system, make sure that it falls in line and it's not an outlier. The Traveler is key to our manufacturing to make sure we produce the same product the same way every time. We do a burst test. We fill it with nitrogen up to 425 psi. From there, we'll go to a helium test. I fill it up to 150 psi, take a sniffer wand through the whole refrigeration system, and they look for leaks. So helium is a really small particle, and it will go through like even the tiniest of leaks. It's smaller than the particles in our R134A refrigerant. Every refrigeration system out there in the world leaks in some sort of fashion. Our set point that we look for on our helium is 0.05 ounces of refrigerant leak a year to make sure that we meet those standards, like we beat those standards. So it's even a tighter set point than it's not really our competitor, but like Carrier and York. That would be our second test. Our third test, run a leak decay test. We'll actually vacuum down to 20 microns, trip that solenoid valve. That micron level will kind of increase and it'll plateau, and as long as it plateaus and it doesn't go above 500 microns, that would mean in our system that you don't have a leak. Then the fourth test is actually before we charge the unit, we do another leak decay test on another system So similar to our vacuum pump, but our charging station also has the same type of test. So we do another leak decay test and it charges the unit. It'll go to wiring. We will do everything to the interior of the unit there. We'll finish everything that we need to. We will then refrigerant leak test. We make sure that the refrigerant leak test has the same set points, the 0.05 ounces per year. And so from when we do that test on, the only thing that goes on is exterior panels.
So my name's Greg Duggan.
I'm Matthew Simpson.
I'm Jared Olson with VoltAire Systems.
The equipment's designed, certified, and listed by UL and manufactured in the United States.